Determinants by diagonals, okay? So, remember when we were talking about the determinant for a 2 by 2 was when we did the ABCD and we multiplied AD and then subtracted it from BC, right?
Yeah.
Little memory bank thing. Okay, so this also is just kind of refresher. If you're in the first position, it's 11, the second position is 12, third is 13. And for this, I use K to represent my total column. Just so that you can see it's different. Instead of having A14, I put it as a K so that you could see that, hey, this is the total column because I got to replace it. Okay? You'll understand here in a minute. So, our determinant is just going to be the first part like it was on 2 by 2s, okay? But in order to multiply up and down, you have to do a little bit more, okay? So it's almost the same process, but you are going to multiply down and multiply up, but you have to add some rows. You can only do this for a 3 by 3, okay? Can't use this method for anything higher than a 4 by 4. Okay, so here's the steps of how to do it, okay? So you extend the grid to make it a 5 by 3. You rewrite the first two columns. So my first column was 5, 3, and 2. And my second column was 0, 1, -1. And the reason I did that was because then I have to multiply each of the diagonals. So there's one diagonal, there's my second diagonal, and there's my third diagonal. Okay? And what you do is you multiply the 3 diagonals down and add them up. So my first diagonal down is going to be 5 times 1 times 5. And I'm going to add to that the second diagonal of 0 times -4 times 2. And add to that my third diagonal of -2 times 3 times -1. Good so far? Okay, so when I multiply those, I'm going to get 25 plus a -8.
Wouldn't it be
Zero.
Oh yeah, that would be 0. My bad. Loopy on cough syrup. -6 times -1 is going to give me a +6. And so my first diagonal is going to be 31. Am I good with that part?
Yes.
Okay, now the second part is multiply my 3 up diagonals and add. So this time I'm going to have 2, 1, 2, -1, 4, 5, and 5, 3, 0. So I have 2 times 1 times -2. I have -1 times -4 times 5. And then I have 5 times 3 times 0. I'm going to put that 0 down because anything times 0 is 0. And that way, even though I'm loopy on cough syrup, I'll remember that this trip around the block. Okay, so 2 times 1 is 2 times -2 gives me -4. -1 and 4 is 4 times 5 is 20. And so this is going to equal 16. Okay? And then my very last step is just like before, subtract top and bottom. So 31 minus 16 gives me a determinant of 15. Kind of putsy, but it's not hard.
This is
Mhm.
long.
Yeah. It takes some steps, but it's not hard. Yeah.
So we're always gonna rewrite into a 5x3.
If you're doing it by diagonals, you have to rewrite it into a 5x3. Or a 3x5, sorry. Tomorrow we'll do it by minors. I'll show you how to do it by minors. So, okay, so when you're solving for Kramer's rules, okay, it's the same thing as when we did the 2x2. Okay, because remember I said I made the totals k because the determinant for the whole thing is still going to be everything on the one side, all your variables, okay? But then when you're finding your d of x, it's the same thing. You replace your x row with the k. And when you're finding your d of y, you replace the y row with the k. And when you have the z, you replace the z row with the z. Or I mean with the k row. Okay. Good? Okay, so let's write our array. So my row 1, is that high enough everybody can see it? So my column 1 is going to be 2, 4, and 6. Column 2 is going to be 2, -1, -1. Column 3 is going to be 1, 3, -1. And then my total is 7, -1, 0. Good? Okay, so what's my determinant array going to be? What do you think? What's the determinant array is going to be? Huh? What's the first D going to be?
Actually, no, it's just going to be the top one.
Yeah, it's just going to be my first 3. So the regular determinant's going to be the first 3 columns.
Yeah.
Okay, so for Z, what do I want to do?
X.
To find my determinant of Z, how am I going to write the array? Huh? Oh, that's what I mean, X. What am I going to do?
Take K and replace.
Yes, it's gonna be
Take
7.
K and put K in for my X row. So it's going to be 7, -1, and 0. 2, 4, 6. Oops, no. 2, -1, -1. Sorry. And 1, 3, -1. Because since it's just the Z,
Wait, why did you switch it out? Oh.
I'm doing the determinant of X. So I replace my X row with the K row. The other two stay the same.
Is K basically like your total?
Correct. Okay. All right. So the D of Y. What am I going to do?
Just replace K with 1.
replace my Y row with K, and everything else stays the same.
Holy crap, I just realized something.
What's that?
Size Z.
This should be C.
Look at the other of the alphabet.
Mallory's got it.
Wow.
She's on it.
Yeah.
Done right.
Okay. All right. So Bib, what am I gonna do for the D of Z?
You replace the zero. You replace the regular numbers with the other numbers.
No, I like the replace the 0 with the K row, or Z column with the K column better.
Yeah.
Sounds a lot more mathy.
That's what she meant.
That's what she meant. Okay, so hardest part, setting up the right arrays, okay? All right, so let's find some determinants then. Okay, so first step is to extend the grid. I think this is the hardest part because drawing my diagonals, if I don't have them lined up, I always screw them up. So if I extend my row, I have 2, 4, and 6, and then 2, -1, -1. Do we agree with that part?
Yeah.
Okay. Let's do the down diagonals. So 2, -1, 1's one of them. 2, 3, 6 is the next one. And 1, 4, -1's my last one. Okay. Let's multiply. So 2 times -1 is -2. -2 times -1 gives me 2. Then I have 2 times 3 is 6. 6 times 6 is 36. 1 times 4 is 4. 4 times -1 is -4. So my down diagonal is going to be 34. Okay. All right. Now I'm going to multiply up my diagonals. So I'm going to get 6 times -1 is -6 times 1, -6. -1 times 3 is -3 times 2 gives me another -6. -1 times 4 is -4 times 2 gives me a -8. And so that's going to give me 12, a -20. Good. Last step, subtract the up from the down. So 35 minus a -20 gives me 54. How we feeling about these? Just kind of putsy.
Putty. When I think putty, I think of putty.
You always say that.
That's a good word. Okay, let's find the D of X. So, I've already replaced my K in my X row. So I just need to extend it. So that's 7, -1, and 0. And then 2, -1, -1. All right, here we go. Let's do the down diagonals. 7, -1, -1. 2, 3, 0. And 1, -1, -1. That's why I said it's kind of hard when you, especially with the negatives when it's typoed or typed. It makes it hard to kind of adjust. All right, so 7 times -1 is -7 times -1 gives me 7. 2 times 3 is 6 times 0 is going to be 0. And 2 negatives make a positive, so 1. So I'm going to have 7 plus 1 equals 8. Yes? Yeah. Uh-huh. All right, so now let's go up the diagonals. So I'm going to have this one, and that one. So my first one's 0, because anything times 0 is going to give me 0. My second one, I have -21. And my third one, I have 2. Okay. And so that gives me a -19. And when I subtract, I get 27.
Oh, yeah.
Good? Now, go back down to using Kramer's rule. If I want to find x, that means that since d of x was 27, and my determinant was 54, that means my x is 1/2. Okay? And then if we didn't have a delay and we had more time, we do the last two, but you do your y and your z. So we'll pick up tomorrow with y and z. So, no Math Excel homework this week because your last page, there's 4 for diagonals, and then there's going to be 4 for minors, which we'll do tomorrow. Okay? So, practice your diagonals tonight.
This is Miss Meyer.